So here we have question from the topic of probability from the IGCSE Extended Maths Past Papers subject code 0580. So the questions are from first question from November 2003, paper 4, question number 5. So you can see here we have Adam writes his name on 4 red cards. So these are the red cards. So Adam wrote his name on it. Daniel writes his name on the 6 white cards. So these are written on the 6 white cards. Now the experiment is one of the 10 cards is chosen at random. Find the probability that the letter on the card is D. So we will see that how many cards are satisfying this condition, which means the card is written with D. So it means it is this one and it is this one. So out of these 10, 2 cards are having the letter D on it. So we can say that how many cards are satisfying the condition 2 divided by how many cards are total, which means all possible outcomes are 10, and 2 of 10 are satisfying this condition. So 2 over 10 is the answer of this. Or in simplified form, we can write it as 1 over 5, or we can write it as 0.2. So we can write either 1 over 5 or 0.2. Then the second part, same experiment that one of the 10 cards is chosen at random. Find the probability that the card is red. So in these 10 cards, 4 cards are red. So it means 4 cards are satisfying this condition, and overall the cards are 10. So 4 over 10, which means either we can write 2 over 5 or we can write it as 0.4. Again the same experiment that one of the 10 cards is chosen at random. Remember, for finding the probability, the experiment consideration is very important. That what is the experiment? So the experiment is one card out of the 10 card is chosen at random. Find the probability that the card is red or the letter on the card is D. So either card will be red, so it means one of these 4 cards, or the letter on the card is D. So which means these 4 cards are D. So overall we have 5 cards which are satisfying either this condition or this condition. So it means it will be 5 out of the total 10 cards. So it means half, or we can write it as 0.5. So or means that either that outcome which is satisfying the first condition, or it is satisfying the second condition, or it is satisfying both conditions. So this is the result of that. Now same experiment, and we have to find the probability that the card is red and it is card on the letter on the card is D, which means it is D as well as it is red. So it means only this. So it means it will be 1 out of 10, because the experiment is that one card is chosen from the 10 cards. So the denominator will be 10. So either we can write this or we can write the answer as 0.1. Okay. Then we have same experiment, and we have to find the probability that the card is red and the letter on the card is N. So as we know that AND means it means satisfy both the condition, this condition as well as this condition. So we have not found any card in the red cards on which the letter written is N. So it means 0 card has written N, and which is red. So 0 out of the 10, because the experiment is out of these 10 one card is chosen. So denominator will be 10. So the answer is 0. So remember, the experiment is very important in solving the probability question. So in all these parts, the experiment was that one of the card from the 10 cards is chosen at random. So that's why in every part you have seen that the denominator is 10. Okay, now we will see the next part. So the next part of the question, part B, if I copy this here, so then it will be easy to solve. Okay, so this one I'm copying here. Now we'll see the experiment in part B. What's the experiment? So Adam chooses a card at random and Daniel chooses one of the remaining 9 cards at random. So Adam is choosing one card from all 10 cards, and then Daniel chooses one from the remaining 9 cards, which means that one Adam is taken, after that 9 cards will be left over. So the Daniel will take one card from the remaining 9 cards. Okay, so this is the experiment. Now, giving your answers as fraction. So here is compulsory to give the answer in fraction. If we don't give the answer in fraction, then we will not get that mark. 1 mark we will lose. So find the probability that the letters on the 2 cards are both D. Obviously, we'll have 2 cards. One Adam will select and the other Daniel will select from the remaining 9 cards. So 2 cards will be there. So we have to find the probability that both cards are D. So first we'll see that the Adam selected the card is D. So Adam has selected D, has a probability of 2 over 10, which we did in the previous part also. So for the probability that the Adam is chosen is 2 out of the cards 10, and we multiply from the remaining 9 cards. Daniel is taking one card and the letter on that card is also D. Since one of the D is already taken by Adam, so now only one card is left for the Daniel, which is written with D, and the remaining 9 cards are there. So it means the answer will be 2 over 90. So in simplest form, this fraction will be 1 over 45. So we have given the answer in fraction form. Now part 2 of B. Find the probability that the letter on the 2 cards are both A. This is also similar to the previous part. So here uh, both A means how many A's are there? 1, 2 and 3 A's are there. So it means when the Adam will select, there will be 3 with letter A on it. So out of the 10 cards, and then the Daniel will select. So we'll have 9 cards left over, and one card A is already taken. So remaining 2 A's will be there. So it means this will be 2 out of the remaining 9 cards. So this is when both the letters on both the cards are A. So now we'll simplify it. So it will be 6 over 90, or in simplest form it will be 3 over 45. Okay, then same experiment, that Adam will take one card and from the remaining Daniel will take one card. Find the probability that the letters on both cards are the same. So same cards. Same cards will be, or obviously it will be either an A or it will be D, because there is no other letter repeated in these letters. So either there will be 2 D's or there will be 2 A's. So if we do it in detail, so this part will be probability that both the cards are A, or the probability that the both cards are written with letter D on it. There is no any other option because we have only one I, one E, one L, one N, and one M. That's why these are the two options. Or means plus, and probability of both A's we already have found. It is 3 over 45, and the probability of two D's we already have taken. It is 1 over 45. So it means it will be 4 over 45. So this is the result of this part. Now the last part, same experiment, and we have to find the probability that the letters on the two cards are different. So letter on both cards are different means that they are not same. So we have two ways to do this question. One way is that using the answer of the previous part, that probability of two different cards is equal to 1 minus the probability of both same cards. And same probability we already have found in the previous part. So it will be equal to 1 minus the probability of same, which is 4 over 45. So we got the answer. 1 minus 4 over 45 will be 45 minus 4 over 45, and in simplest form it will be 41 over 45. So this is one of the way in which we use the answer of the previous part. Or alternately we can do it in this way. Probability of two different cards. So it means that it will be either first one letter A, second one D, or means plus. It will be probability of first one is D and the second one is A. So this is the alternate way to do this question. But the previous way, which I wrote in blue, is easier because we use the previous part here. Okay, here if we are to do in this way, so the experiment is that two cards are taken, first out of 10 and the second out of 9. So it will be first A, there are 3 A's in the total is 10, and now total is one short, which means it is 9, and there are 2 D's, so it will be 2 out of 9. And plus, out of 10 the probability of D is 2 over 10, and A, there are 3 A's and total left over are 9. So then we will simplify these. So you will see that we will also get the same answer. So 6 over 90 plus 6 over 90. So it is 12 over 90. So when we simplify 12 over 90, so it's not 41 over 45. It means there is some mistake in this working, which I showed in green color. The mistake is that when it is written different, it means both cards are different, which means we have not considered the other cards, because if one is A, the other will be not A. It's not compulsory that it will be D. It may be L, E, I, or M. So that's why this working is not correct. So it means that I will now write the correct working. So this is not this one and this one. So it means now it will be different. So first I did with this way so that you remember that if you're doing in this way, it is not correct. Okay, so now one card is A and the other is not A. It means not A, we write A prime. And one card is D and the other is not D, means D prime. Okay, now for A out of 10, there are 3 A's, so 3 out of 10. and from the remaining 9 cards which are not A will be 7, because we have 3 A's and 7 not A's. If you want to see what are those, so we can mark them. This is not A, not A, not A, not A, not A. So 1, 2, 3, 4, 5, 6, 7. So it means this will be 7. And similarly, if 1 is D and there are only 2 D's, it means the remaining 8 cards are not D, which you can say 1, 2, 3, 4, 5, 6, 7, and 8. So it means this will be 8 out of the remaining 9 cards, because one card is already taken. Okay, so now if we simplify these, so it will become 21 and 8 to the 16. So when we add them, so we got 37 over 90. Still we are not getting the same answer. Basically there should be 82 options out of 90 which will be different cards. Why still the answer is not same? Because we have not considered some more options. We have considered only that one card is D or one card is A. If you think in detail, so we know that there might be one E and one L. So these are also two different cards. One I and one L, one N and one L, one N with one E. So see, there are many options there. So either we will find all those options, which will be quite a lot, because the total should be 81 out of 90. So that's why this working which I did here, this is quite short as compared to this working. So either we'll consider all the other options, and then after that we will get the final answer 82 over 90, which will simplify to 41 over 45. So it's not good to do it in this way in the exam, because the time is always limited there. So this way is better. That probability of two different means 1 minus probability of both same. So this way is better. Okay. Okay, now the question, next question, which is June 2007, paper 2, question number 15. So here the experiment is two unbiased spinners are used in a game. Unbiased means that all the outcomes have the same probability. So one spinner is numbered from 1 to 6 and the other numbered from 1 to 3. So one spinner is shown here. If I mark them with blue, so this is the first spinner, and the other spinner is this one. If I mark them with orange, so since both are unbiased, it means the probability in the first spinner to get 1, 2, 3, 4, 5, 6 is same. And similarly, the probability in the second spinner of 1, 2, and 3 is the same. Okay, so now the experiment is that the score on each spinner are multiplied together. So the table shows the possible outcomes. So this is the experiment, that one of these outcomes will be taken. So these outcomes which are written in bold. So half of the question is already solved in here for our easiness in the exam. Otherwise, sometime we have to complete this table. So how to complete? Because we are to multiply. So we have to multiply both the outcomes. So 1 times 1 is 1, 1 times 2 is 2, and so on, like 3 times 6 is 18. So we multiply both and we write here. It means that the outcomes are, for this experiment, if I mark them with pink color, so are these. So these are the outcomes. How many are these? These are 6 times 3, 18. So total 18 outcomes. So the denominator of the probability will be 18 in this case. Okay, so find the probability that outcome is even. So now let's see how many even numbers are there. So even numbers, if I mark them, even this 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So it means it is 12 and total outcomes are 18, and in simplified form both are divided by 6, so it will be 2 over 3. So the answer is 2 over 3. Okay, so in every probability question we will always think that what is the experiment. So and then after experiment we'll see what are the outcomes, and then we can continue to solve the question. Now the second part, same experiment, that one of the number from these outcomes is chosen randomly. So we are to find when the outcome is an even. So it is actually a double condition question. We also call conditional probability. So when the outcome is even, it means we are not to take from all of them. We have to consider only from the even numbers, which I underline with the green color. So it means from these 12 outcomes which are even numbers, 12 outcomes which are even numbers, so the denominator will be 12, and which are satisfying this condition, find the probability that it is also greater than 11. So how many of these green numbers are greater than 11? Greater than 11 means not equal to 11, only greater than 11. So we have only this number greater than 11, this one and this one. So remember, we will take only from the even numbers, not from all the 18 outcomes. Okay, so 3, so it is 3 out of 12, which means it is 1 out of 4. So the answer of that will be 1 out of 4. Okay, so this is the solution of this. Now there is another question. June 2008, paper 4, question number 3, part A. So here the experiment, bag A and bag B are shown. Nadia must choose a ball from bag A or from bag B. So she is choosing either from A or from B, one ball. Okay. So to make the situation easy, first it's better if we write them here. 1, 2, 3, 4, 5. 5 white are here and 3 black. Okay. Here 1, 2, 3, 4, 5, 6. 6 white and 2 black. So the probability that she chooses bag from bag A is 2 over 3. So see it again. The statement is the probability that she chooses bag A is 2 over 3. So it means there is more chance to select from bag A. So bag A is chosen first. So remember, the experiment is first the bag is selected and then from the bag a ball is selected. So it's given that the probability of choosing bag A is 2 over 3. So probability of this bag is 2 over 3. So it means that the probability of the other bag will be 1 minus 2 over 3. So that will be 1 minus 2 over 3. So this is 2 over 3. So which will be 3 minus 2 over 3, which is equal to 1 over 3. Okay. So bag A contains 5 white and 3. So this already we wrote here in short. So the tree diagram below shows some of the information. We know that the tree diagram is always used to make the situation simple for us to understand. Okay, so here some of the outcomes are already filled and some of the other outcome we have to fill. So filling the tree diagram is very simple. See, uh, find the values of P, Q, R and S. So we know that in the tree diagram from one root, if some branches are coming out, so the sum of the probabilities in that is always equal to 1. It means 2 over 3 plus P will be equal to 1. It means P will be equal to 1 minus 2 over 3, which we already calculated before, which is 1 over 3. Okay, so that means the value of P is equal to 1 over 3. Now we have to find the Q, and from this root, two branches are coming out. So it means the sum of these two will also be equal to 1. So it means Q will be equal to 1 minus 5 over 8. So 1 minus 5 over 8 is 3 over 8. So it means Q is equal to 3 over 8. And then the value of R. Now here we cannot do because both are not given. So it means we will use the basic detail of the question to find the value of R and S. So this is bag A selected. So in bag A we have this situation. So if I copy it here so that you can see the tree as well as this one. So here R. So from the bag B, probability of a white ball, white are 6. So it means this will be equal to 6 over total, 6 plus 2 total is 8. So 6 over 8, which can be simplified to 3 over 4. Okay, so it means R is equal to 3 over 4. And then S will be equal to, because from this branch two branches are coming out, so S will be equal to 1 minus R. So it means this will be equal to 1 minus 3 over 4, so which will be equal to 1 over 4. So S is equal to 1 over 4. You can also do it directly from the situation, like this is the probability of black, so 2 out of 8. So 2 out of 8 means 1 over 4. Okay, so then this is the first part of the question. Now when the tree is complete, so we can do any part which is asked related to this experiment by using the tree. So part 2, find the probability that the Nadia chooses bag A and then a white ball. So bag A and white ball. So in bag A, white ball. So it means this and this. So whenever we go horizontally on the tree diagram, we multiply the probabilities. So it means probability of bag A is 2 over 3 times the probability of white in this one is 5 over 8. So it's 5 over 8. So it will be 10 over 24, which will be simplified to 5 over 12 after simplification. And then the last part, find the probability that the Nadia chooses a white ball. Here the bag is not mentioned. It means the white ball will be either taken from A or the white ball is taken from bag B. So it means that first from A and white and then from B and white. So from A and white, if I write in detail, it will be first bag A and then white, or means plus probability of bag B and white. So this will be equal to, already we have done this here, so I'm writing in short this one. So it is 5 over 12 plus the detailed working is already done here. So from the bag B, which is 1 over 3, and white here is 3 over 4, so it is 1 over 3 over 12. So total will be 3 plus 5, 8 over 12, which means 2 over 3. So this is the answer for the last part, 2 over 3. Okay. Now there is another part B. So remember, the layout of the question is like this, that here after question 3 written part A, it means this whole is part A till here, and then parallel to A, B is written, so it means this is a separate question. It is not having any relation with the previous part. So we will solve this. So I will put it a little bit down. Yeah. So here. So another bag contains 7 green and 3 yellow. So we can write 7 green and 3 yellow. So the total is 10. This is the situation. Sani takes 3 balls out of the bag. So 3 balls is the experiment without replacement, which means that 1 ball is taken out, and then another ball is taken out, and then another ball is taken out. So 3 balls will be outside. So it will not be replaced back. So each time when you take one out, so there will be one short in the bag. Okay. So find the probability that all 3 bags choices are yellow. So it means for this part 1, we have to find the probability that the first one is yellow, second one is yellow, and the third one is also yellow. So first yellow means there are 3 yellows and total is 10. Now since now 1 ball is out, it means in the total we'll have 9 balls left, and in these 9 balls there will be 2 yellow because 1 yellow is already taken out. So 2 yellows, and then total 8 are left behind, and then 2 yellows, so one, there is only 1 more yellow left, so it will be 1 over 8. So since all 3 are yellow, so first 3, then 2, then 1, and first before there was 10 total, then 9, and then 8. So then we will simplify this. So after simplification it will be 1 over 20. You can use calculator here also because it's allowed. Okay. Then part 2. Find the probability that at least one of the 3 ball he chooses is green. It's only 1 mark question. It means there will be a shorter way. Otherwise, if you do in detail, it will be a quite long working. So remember, whenever there is a probability of at least one of some condition, and the condition is green. So probability of at least one in the 3 is green. So probability of at least one green is equal to 1 minus the probability of no green. No green means all the 3 balls are not green. If they are not green, it means they are all yellow, because we have either green or yellow. So it means this is equal to 1 minus the probability of yellow, yellow, yellow. So it means it is 1 minus the answer of the previous part, which is equal to 119 over 120. So this is the answer for the part 2. So remember, whenever it is at least one of some condition, so it means 1 minus the probability of not that condition. This will make your solution simple. Okay. I hope all these 3 parts questions are clear. Okay. Have a nice day.